All right. Today we want to talk about graphing a quadratic and then determining what its solution is by the graph. And so the first thing we need to know that the solutions to graphs, or the solutions to quadratic graphs, in particular parabolas, are always called roots. They have several names: solutions, zeros, roots, and all these names mean something, right? Because if we were to look at the graph, the solutions, the roots, the zeros all mean that it's where the graph intersects the x-axis. So if we were to take a look at the graph, let's say the first problem, and I'm not going to go over how to graph them because that was lesson 1. So if you need to remember how to graph these things, I need you to go back to lesson 1. But if we want to talk about what the roots and solutions are, we'll take a graph. Let's say the first problem for this lesson, y equals x squared minus 6x. And if you look, I'm looking down here, x squared minus 6x plus 3. I'm going to enter that into our program, and let's see the graph. All right. So now that I'm looking at this graph, I see that its roots, solutions, or zeros, and we'll talk about why each of those makes sense, are approximately right here. And there are two roots. There are a couple things that are interesting here. What I need you to know is where the root is and how to determine what the root is. But there's another thing that I think is extremely interesting here. The highest degree of this polynomial is 2. Therefore, the fundamental theorem of algebra states that the degree of your polynomial will tell you how many solutions there are. So since the degree of this polynomial is 2, there should be 2 solutions. And there are 2, point A and point B, in this particular graph right here. So let's take a closer look at these solutions here. I noticed that this first solution is between 0 and 1. And so that's what I want to say. I'm going to say that the first solution is in between 0 and 1. And that's what I would write on the paper, between 0 and 1. The second solution, however, is between 5 and 6. I would also say that on the paper. The second solution is between 5 and 6. When I ask you to approximate, I'm not going to ask you to go in deep in there and say, well, this is 56 hundredths, and this over here is 5 and 47 hundredths. I'm not going to ask you to do that. I just need you to tell me approximately what two integers the solution is in between. Don't forget, in a parabola, there are going to be 2 solutions, right? That's only if your graph actually crosses the x-axis. If it does not cross the x-axis, you want to say that your graph has no real roots. And so, since this one does cross the x-axis is here, we're going to say that there's one solution here and one solution here. Then we'll say this solution is between the integers 0 and 1, and this solution is between the integers 5 and 6. One interesting way to remember what solutions, zeros, and roots mean: zeros means where your y value is 0. Your y value is 0 always on the x-axis. Roots mean where something begins or where something starts from. And so if you want to think of it in terms of roots, when we're dealing with parabolas are always used to find out projectile motion, that is, if something is being thrown or launched, which typically looks like this. Now, when you're talking about when something is being thrown or launched, your x-axis would be your ground level. And so where it crosses the ground level would be the root, where it started from. And so when you think of what is the teacher asking me, or what is a math problem asking me, or what is a real world problem asking me when they say find the roots, they're asking you to find out where it crosses the ground level. And the ground level is the x-axis. All right? And so what I need you to do is find out the roots to all of the problems I gave you on this sheet. There are 5 of them, including this one we just did. And if it lies within 2 integers, I need you to tell me which 2 integers it lies in between. For example, this one, I would say it's in between 0 and 1, and we have another root in between 5 and 6. If it lies directly on an integer, tell me which integer it lies on. And if your graph does not cross the x-axis, you say it has no real roots. Do all those problems. Have a great day.